Today we'll be looking at the Log Analyse Sysmon challenge provided by Blue Team Lab online. We can see we're provided with a Sysmon log of a compromised endpoint, and we're tasked to analyze the logs and find out the steps and techniques used by the attacker. So today I'll be going through getting started with the logs, not necessarily going through the questions, but drilling down on some of the techniques used. So let's get us started. So to get us started, we'll just download the Sysmon log file from the web page. We can save this to our local machine. Also just move the downloaded file to our current directory, and we can unzip the zip file. The password you should be able to find on the website, which would be BLTLO. Once extracted, you can see we're presented with a Sysmon events.json file. So just heads on this file, we can see it's the JSON version of the Sysmon logs. So to be able to search the logs more efficiently, we're going to use a software called Splunk. And to be able to install it easily on our Kali box, we'll just use the Docker instance of Splunk. So just Google searching Splunk Docker. We can go to the hub.docker.com site to get the install instructions as well as the quick start command. So once Docker is installed on a Kali, you should just be able to run the docker pull command provided here, which would pull the Splunk container or image. And then just scrolling down to the quick start guide, we'll just use this command provided by them to start a local Splunk instance on our machine. Also just changing the Splunk password. You can see we have to run this as sudo, so just rerunning that command with sudo. And we should now have a Splunk instance running on our machine. Just nmap localhost, you can see we have port 8000 open. So now just navigating to localhost 8000. It should now load our Splunk instance. It might take some time for the instance to start up. Just checking if it's running under HTTPS, which it doesn't look like. Just drop the HTTPS again. We can see our Splunk instance starting to boot up. So once your Splunk instance has booted up, you can just log on with admin change me. And this should load us into Splunk instance. The next step from here would be adding our data into our Splunk. So we can just from the home page go to add data. And then we'll just skip the tour. We can select upload from my computer. And then under select source, we'll just select the file we want to upload. We'll just go into our YouTube directory and upload the Sysmon events.json file. Once uploaded, we'll just select next. You can see already selected our source type for us as JSON. We'll just keep it like this, just confirming that our data looks correct. And you can see the field extractions looks like it's working, so we'll just go next. The input settings, we can just leave this as default, go to review, and so. So now that our data is in Splunk, we can start searching those data. Just select start searching. So now we need to start making sense of the events that happened and occurred and see if we can start getting our foot off what is the steps and techniques used by the attacker. So to start us off, we can get the event IDs of all the events that happened. So just on the left hand side should be all our fields available. And we'll just grab the event.system.event ID field. And inside our search, we'll just make a new line, pipe stats, count by our field event ID. Just sorting by the count. You can see we have a lot of event ID 11s, a lot of event ID 1s, a lot of event ID 3s, and to get the definitions of these event IDs, we can just search Sysmon event IDs. This should take us to the Microsoft documentations for Sysmon. We can see what each ID represents. So just scrolling down the documentations, we can see event ID 1 is process creations, event ID 11, which was the highest count event. You can see there's file creations and so on. It's good to familiarize yourself with these event IDs. Event ID 3 is network connections. So now that we have kind of understanding of what are the events that happened, let's see if we can see this on a time chart. So just changing our stats command to time chart, and this then should show us events happening over a set period of time. So we can see we have our event ID 1, which was a process creation, followed by the event ID 11s, as well as 22, which would be DNS request, and event ID, which would be network connections. So to dive deeper into this, we'll start looking at the event ID 1s. So just duplicating my tab. You can start by looking at what are the event ID 1s occurring. So we'll just place a filter on show me only event ID 1s, and we'll just remove any stat commands. So just showing us the raw logs. Just from this first one, we'll just say show all lines, so we can see what is inside the log for us to be able to search. We can see the event data. We have a lot of information, like the command line, the company, the current directory, description, also original file name and parent command line, and parent images used. So to start us off, we'll just look at what are all the command lines happening. So to be able to get this field name, we'll just drop down this. Scrolling down, you should see these are all the fields available for us in Splunk. And we can grab the event.event data.command line field. And then we'll just stats count by that field. If I can type. So this should now give us a a static list of all the commands that was executed within these logs. So just starting from the beginning, we can see Google Chrome, we can see Analyse HTA, which seems to be executing a HTA file, followed by PowerShell with encoded command, followed by the event viewer.nsc, another PowerShell command, which looks to be the unencoded part of the previous command. Also see Sysmon running, as well as CMD. Just looking down, we can see there's also supply.exe, a juicy.exe being executed, as well as another PowerShell command being executed from that supply.exe binary. And at the bottom we can see an invoke web request downloading that supply.exe binary. So just from this, we already have a lot of more information of what are some of the commands executed on this machine. And some of these commands we can see looks very suspicious and malicious. So just looking at some of the other event IDs we saw as well. Just duplicating my tab again. And then this time we'll put our filter on event ID 11. Just removing our stats command to get the raw logs. And we can start seeing what are some of the fields or logs for event ID 11. So just show all lines. You can see we have the event data again, which shows us the image, the rule name, and then the target file name. So this target file name would be the file created by this image. So we can see here this log, we can see the supply.exe binary creating this Python 27.dll file. You can also just values all the target file names to get a list of all files created by this binary. So we'll just take that event.data.image field again. And then we can stats count by that image. And then we want to see the values containing the target file name. So showing us all target file names created by that image. So just getting the event.data.target file name field. And we can put that in our values command. And you can see we have Chrome, which looks to have been downloading that updater.hta file. We also have Sysmon, as well as PowerShell. You can see downloading that supply.exe binary. And then that supply.exe binary dropping all of these DLLs, where you can see Python.27, which suggests that that binary requires the Python.27.dll, which might mean it's written inside Python. Just scrolling all the way to the bottom, we can see that's all we have. Just duplicating my tab again so that we can look at the network connections made for event ID 3. So just following the same process as the previous ones, we'll filter on our event ID 3 and remove all stats command. So we're left with the raw logs. And then just looking at what we're dealing with. So you can see for event ID 3, we can see the event data shows us the destination IP, the destination port, the image again, as well as the source IP, source port, and the host name. So we want to see basically what are the outbound connections made from these images. So we'll just do a stats count. So just do a stats count by that image field. So just grabbing the image field again, event data.image. As well as our event data .destination IP, as well as the destination port, and our source IP, as well as our source port. Just to make it more readable, I'll just put the source before the destination. And we can see our connections made outbound. So you can see PowerShell coming from source IP 192.168.1.8, going to source IP of destination IP 192.168.1.11 on port 123, as well as port 969, and then the rest we can see going to port 8080, which most likely is going to be the C2 connection. So just going back to our command lines, let's see if we can see this corresponding with our command lines ran. So just looking at the 6969 IP of port, we can see that is where the download for the supply.exe connected to. You can also see here the netcat.exe binary trying to reach out to 192.168.11.1.11 to 98.98, but we can see there's no actual connection outbound to that port. So we can assume that this command did not run successfully. So the next step in looking is where can we see this 1234 port. Just looking at the command lines executing, we can't really see any connections to that 123 port. So the next step would be, let's see if we can see what this encoded PowerShell command is executing. So I'll just copy that encode part, and we'll copy this to file on our local machine. Just opening Sublime and calling this encoded.ps1, and we can paste in that encoded string. We'll just, from our terminal, cat that file for us to be able to base64 decode this, and we can then read that into a new file, unencoded.ps1. I see we got an invalid input error. Let's just see if that file was created, and it was successfully decoded, so I'm not sure what that error code was. We'll just open this in Sublime again, and we can see we have the unencoded PowerShell command. So just adding word wrap, we can see what we're dealing with, and we can see we have an if, and it's looking for the PowerShell or the full path to PowerShell, and then executing what looks to be the next arguments. So to be able to make this more readable, we'll just break each semicolon with a new line, and we can see what it's trying to do. We'll just see it's trying to get the PowerShell path that's available, creating a new object and executing that with this argument. So again, we can see we have from the arguments, it's going to execute hidden, and it looks to be gzip stream, so it's going to be gunzip, and then decoding also from base64 string. So let's take this base64 string and see if we can decode this as well. So I'll just make a new file, call it stage 2 encoded .ps1, and can paste in this string. Just decoding it the same way, we can cat that stage 2 and then pipe that into base64, tag D to decode it, and we also saw it was gzip stream, so we can just unzip that with gunzip and read that into stage 2 unencoded, or actually decoded .ps1. So just opening our stage 2 decoded PowerShell file, you can see we have what looks to be the final payload. So just going through this, we can see we have another base64 string, and as well as calls to virtual alloc, which suggests it's going to load it into memory. And furthermore, we can't really see much more. So let's just see if we can find out what this base64 string is. So we'll just highlight this. And then save that into, say, stage 3. Encoded. And we'll just save this. And then just cat that file. And see if we are able to base64 decode this. We can see it doesn't really look like any data or clear text data for us. So what it might suggest, this might be the shellcode that's being loaded into memory. So we'll just run that command again and pipe this into possible shellcode .malicious. Let's just run strings against this to see if we can find any. Before we run that, we'll just run file on that file. And you can see it's just data. If we try and strings this to see if there's any strings present in this file, we can see there's not really anything that's human readable. It's not really giving us, or it's not really giving away what it's going to execute. So there is one way to be able to reverse the shellcode, and it's a tool called scdbg, which would basically step through each command without executing it and essentially show us what this shellcode is going to execute. So you should be able to just download this binary, which was scdbg.exe. So just Google searching on that binary, and the first link, Sanskrit, you should be able to go there. And scrolling down, you should see the 132 binary, which you should be able to download. Which I already downloaded on my system, so I'm just going to cancel. And then to be able to run this, you're going to have to install wine on Kali, which I already have on my system. So I'll just run sudo wine as well as that binary, which is under ops tools forensics and then scgbd. And then we'll just run tag s, which is going to specify the amount of steps it's going to take. We'll just specify -1 so that it will run till the end of the shellcode. And then tag f to specify the file containing the shellcode, and we'll just specify that possible shell.malicious. So just running this, it should now step through our shellcode and show us what it's going to execute. So once that has executed, we should see the commands that it will execute. And as you can see, it's now stepping through the shellcode. And you can see, just scrolling up, we can see there's a load library, ws2_32. And then we have the connect command, which will connect to host 192.168.1.11 on port 1234. And then going back to our Splunk logs, we can see that is where we saw the 1234. So that was the initial breach and possibly the backdoor into this machine. So just going back to what the shellcode is, we can see from experience this looks familiar. So just starting up MSF console, let's see if we can get that exact same payload from one of the MSF console modules. So also just going back to our Splunk logs, we did see this updater.hta file. So let's see if that was a Metasploit malicious file. So inside Metasploit, we'll just search for HTA. We can see there's the exploit windows.hta server. So we'll just use 2 to load that module. Just going options. You can see our other host is set to 192.168.127.130 on port 4444. And we can just run this module. So you can see we have now our local IP and hosting that HTA file. So let's just download that to our local machine. So I'll just download that. So just opening that HTA file, you can see we have a PowerShell command that's going to execute hidden and execute this encoded command. Let's just see what this encoded command is. So instead of doing it in terminal, I'll do it this time inside CyberChef. So just pasting our encoded PowerShell command inside CyberChef and then decoding that from base 64. You can see we have this second stage payload, which sometimes if you decoding PowerShell or Windows base 64 within CyberChef, you have these extra dotted characters. So just to remove this, we'll just load the regular expression recipe as well, and that should remove the extra dots. And we can see we're left with the following payload. So just copying this out into a new Sublime window. And we can save this as MSF console HTA payload .ps1. And then also just doing a word wrap on this and replacing all semicolons with a new line. And we can see this looks a lot like our unencoded PowerShell command from earlier. So just going further, we can extract this base 64 string, which you can see the only difference with ours is it's appending. So just running this inside terminal. Let's see if we can get. So we'll just open up PowerShell inside Kali and then execute that. Let's just see if we can decode this. I think I missed the bracket. I'm still not. Let's just replace all of those double quotes with a double quote. See if that makes the difference. I'll just copy that again, run it inside our PowerShell, and we see we have unexpected token, so we're missing the beginning bracket trail. So just taking that bracket, copying this again, and executing that. You can see that deobfuscated for us. So we can now just take this base 64 string and read it into our CyberChef terminal again. Just moving all the recipes to start fresh. And I just want to remove that base64 now, so I'll just paste this in. You can add the base64 decode recipe. Let's remember it was gstream, so we'll just have to add the gunzip recipe to uncompress this data for us. And we can see we're left with this final stage, which again looks exactly like our previous command with some differences. So let's see if we can also decode this shellcode again and see if we see the same results. So just getting a new terminal, and we can echo that base64 string, and then base64 decode this and read it into NFS console. Underscore shellcode dot malicious. And then we can just run sudo wine followed by our scdbg binary. Set the steps to -1 and specify the file msf console shellcode. As you can see, stepping through the shellcode again. Just scrolling back up, we can see the load library ws2_32, as well as the connect to host 192.168.127.130 to port 444. And going back to our HTA server and our interpreter session, we can see that was our Analyse and port. So we can confirm this was a interpreter reverse shell that ran on this box. So that will conclude this video. Thank you for watching. Hope you enjoyed this content. I'll be making more of these videos soon.